Number 9, which of the following nuclei lie within the band of stability? And then we have iron 56. So we have Fe, which is iron, with a 56 at the top, right? And 56, always the number at the top, is always going to be your atomic mass. Now, atomic mass, the two subatomic particles that are in atomic mass is your protons, and you got some neutrons in there as well. Now, if we really wanted to find out, if this isotope, or if this nucleus, right, the iron with the 56 total protons and neutrons, if this is stable, aka is it in the band of stability, we have to find out how many protons and how many neutrons it has. Now, we know that it has a total of 56 combined, but how am I going to find out how many protons and neutrons total, right? Well, the first thing is that for every individual element, there always is going to be a number on the bottom. And that number is your atomic number. And every element has its own specific and unique atomic number. We must go on the periodic table to find that out. Now, if you have your periodic table in front of you, whip it out, right? Let's go see. I'm searching for iron on mine, and I see that I have a 26. So I got a 26 for my atomic number, and the atomic number is always the number of protons. So once you find that atomic number, that's the total number of protons. We got 26 protons. And now, since we know that we have 56 total protons and neutrons, and we have 26 protons, I could find out my neutrons by just doing a little subtraction, right? 56 minus 26 is 30. So that means that I have 30 neutrons. Okay, so your thought process should be always run through your magic numbers first. Now, there's only 7 magic numbers, and if you have your protons or neutrons equaling these numbers, so 2, 8, 20, 28, 50, 82, and 126, you are going to be, or the atom is going to be automatically stable. And yes, it would be in the band of stability. But in our example, we have 26 protons and 30 neutrons. 26 and 30 isn't a magic number, so I can't do it that way. When that doesn't work, then we have to actually go to the graph. So here is the actual band of stability graph. Now, stable isotopes are very far and few. Only the blue tick marks and this kind of line here is only the atoms that are stable. All of the green is all of the isotopes or the nuclei that are unstable. So we got way more unstable guys out there than stable. So now we just got to find out where 26 and 30 is on the graph and see if it's a blue or if it's in the green. So let's see. Number of protons, we know that we have 26. So this is kind of a little bit tricky because they don't label the tick marks in between. So I'm going to have to go by steps. So let's see. Here's 20. So that means that this has to be 20. So if I go over, and I think there's 5, 1, 2, 3, 4, 5. Yes, so they're going up by 2. So let's see. 20. So here would be 22, 24, and then 26. So this little line right here are all your 26ers. And let's see. Are we in that band of stability? Well, I have a line that goes out to here, and it's going to autocorrect me. I hope it will autocorrect me. Let's see. There we go. Right on 30. And that's what we have. We have 30 neutrons, and we have 26. If I bring this line down, there it is. That's definitely a 26er. So this checks out. It is part of the blue. Voila. So yes, this is part of the band of stability. But if your atom with the protons and neutrons, if it was in the green, then you would say, no, it is not. And that's it. Hopefully this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel. And I look forward to helping you in more questions. We also have memberships. So if you want to be a member, you could always be a member. And I got to go because someone might be at the door, right? My door might be no more. So So we'll see who's there. Okay, I'll talk to you soon, guys. Okay, bye-bye.